Electric fields, an animated presentation. Everyone's had their experience of dragging their feet along the carpet and shocking their friend. Or rubbing a balloon against your head to get your hair to stick up. The balloon especially works well because it's an insulator that loses and gains electrons easily compared to other materials. And the fun doesn't stop there. There are two types of field, radial and uniform. Most charged particles exert a radial field, but you can create a uniform field using two parallel charged plates. All charged particles exert a force on other charged particles within their electric field, which is asymptotically infinite in the case of point charges. These fields will interact differently, dependent on whether they are like or unlike charges. So, how do we figure out how strong this electric field is? Well, there's more than one way. One way is to use a particle of which we know the charge and the force exerted on it while it is in the electric field. Using E is equal to F over Q, we can work out that the electric field strength is equal to 20 over 5, which is equal to 4 newtons per coulomb. The other is using the equation E is equal to Q over 4 pi epsilon naught r squared. In this case, Q being the charge of the particle creating the electric field, and r being the distance of the test charge away from the original particle. 4 pi epsilon naught is just a constant. In this situation, E is equal to 10 over our constant times by 1.9 times by 10 to the power of 8, which gives us a value of 2.5 newtons per coulomb. You can also find the force between two charged particles using Coulomb's law. Coulomb's law states that the force is directly proportional to the product of the two charges, while inversely proportional to the square of the distance between them. This means that force is equal to Q1 times by Q2 over r squared times by a constant. The value of the constant is equal to 1 over 4 pi epsilon naught, which is equal to 9 times by 10 to the 9. With uniform fields you can also calculate the strength of the electric field. The electric field strength is equal to the potential difference over the distance between the two plates. And that's it for now. This was a presentation on electric fields.